In this lesson, you will learn about the basic components used by air conditioning systems. The components include AC compressor, compressor clutch, evaporator, condenser, high-pressure relief valve, service ports, fittings, lines, and restriction devices. The internal variable displacement compressor, or IVDC, uses an internal pneumatic control valve with a bellows. Variable displacement is achieved by the amount of pressure on the head of the pistons versus the crankcase pressure applied to the back of the pistons. The control valve changes the crankcase pressure based on evaporator heat load. Low evaporator heat loads will cause low suction pressure that increases crankcase pressure and reduces stroke. High evaporator heat loads will cause higher suction pressure that reduces crankcase pressure and increases stroke. The IVDC has a D-stroke spring which returns the swash plate to a low-stroke position upon compressor disengagement. When the compressor cycles off, the swash plate moves to the low-stroke position. This is near zero displacement. When re-engagement occurs, fuel economy is improved due to lower compressor displacement, with reduced torque, also resulting in reduced clutch noise. The IVDC has a higher ability to compensate for refrigerant flow restrictions, which causes diagnosis to be different from other piston and scroll-type compressors. The external variable displacement compressor, or EVDC, has basically the same internal structure as the IVDC. The main difference is control valve actuation is electronically controlled by the PCM. The PCM uses evaporator temperature, ambient air temperature, engine RPM, vehicle speed, AC high pressure, and intake air temperature to determine refrigeration capacity. The PCM sends a pulse-width modulated signal to a solenoid in the compressor to control compressor displacement by altering the swash plate angle. The difference between a variable scroll and a fixed scroll compressor is that a variable scroll uses a control valve to adjust output capacity. The control valve is connected between the high and low pressure chambers of the compressor. Under high loads, the control valve blocks refrigerant flow from the intermediate chamber to increase suction pressure, and the compressor will operate at full capacity. Under low loads and higher speeds, the variable scroll compressor allows partially compressed low-pressure refrigerant from an intermediate chamber to return to the suction chamber. This allows the compressor to function at minimum operating capacity, which could be as low as 30% of its total capacity. The variable scroll compressor is highly efficient at higher RPM, but as a result of the design, it is not very efficient at low RPM, and the customer may notice reduced cooling performance when compared to vehicles with piston or variable compressors. Piston compressors use pistons positioned axially around the compressor shaft and operate within the cylinder assembly. The pistons are actuated by a swash plate pressed on the compressor shaft. The swash plate changes the rotating action of the shaft to provide a reciprocating driving force to each of the 5 pistons. This driving force is applied through shoes to the midpoint of each of the double-end pistons. Reed-type discharge valves are assembled on the valve plate, which is located with the suction reed valve between the cylinder assembly and the head at each end of the AC compressor. The heads are connected to each other by gas-tight passageways through the cylinder assembly, which direct the refrigerant gas to the suction and discharge ports located in the rear head. Scroll compressors employ 2 identical concentric scrolls, one inserted within the other. One scroll remains stationary as the other rotates around it. This movement draws gas into the compression chamber and moves it through smaller pockets formed by the scroll's rotation until it reaches maximum pressure at the center of the chamber. There, it's released through a discharge port in the fixed scroll. During each rotation, several pockets are compressed simultaneously, so operation is virtually continuous. This electrically powered scroll compressor is used on hybrid and electric vehicles to maintain cabin comfort. The basic integral parts of the variable speed electric compressor are a compressor mechanism, a motor, and an electric circuit referred to as the Air Conditioning Control Module, or ACCM. There are two types of expansion valves. One uses an internal diaphragm filled with a temperature-sensitive fluid to monitor evaporator temperature at the outlet of the expansion valve. The other uses an external sensing bulb connected to the diaphragm by a capillary tube and monitors evaporator temperature at the outlet of the evaporator. The evaporator core is located in the plenum assembly. The refrigerant in the evaporator absorbs heat from the passenger compartment as air passes through the fins. As hot, humid air passes over the cold evaporator, the moisture in the air condenses and is drained through an opening located at the lowest point of the heater core and evaporator core housing, usually below the evaporator core. The suction accumulator is located between the evaporator and the compressor. It uses a desiccant bag to remove moisture from the refrigerant and prevents liquid refrigerant from reaching the AC compressor. The suction accumulator allows the refrigerant to vaporize before entering the compressor. A small orifice in the bottom of the accumulator picks up any oil that has gathered in the accumulator and returns it to the compressor through the suction line. The integrated receiver dryer is incorporated onto the AC condenser. Refrigerant flows through the inlet opening of the canister and passes through the desiccant and cartridge. The desiccant removes moisture, and the cartridge filters solid particles from the refrigerant. The refrigerant flows from the receiver dryer through the outlet in the canister to the TXV. The integrated receiver dryer is equipped with a serviceable desiccant cartridge. The receiver dryer is located in the high-pressure side of the AC system between the condenser outlet and the expansion valve inlet. It removes moisture from the refrigerant and prevents refrigerant gas from reaching the TXV. When refrigerant enters the receiver dryer, the liquid refrigerant settles to the bottom of the canister, and the refrigerant gas rises to the top. Refrigerant leaving the receiver dryer flows out a tube with a filter screen that extends almost to the bottom of the canister. The receiver dryer contains a material called desiccant that absorbs impurities and moisture as the refrigerant flows through the canister. The fixed orifice tube is located in the liquid refrigerant line between the condenser and the evaporator. The fixed orifice tube contains a screen to prevent clogging and O-ring seals to prevent the high-pressure liquid refrigerant from bypassing the orifice tube. The fixed orifice tube creates a restriction in the refrigerant system that reduces refrigerant pressure and its boiling point. The state of the refrigerant as it enters the fixed orifice tube is 100% liquid and 100% low-pressure atomized liquid as it leaves the fixed orifice tube. Fixed orifice tube openings vary in size and are designated by their color. The evaporator inlet and outlet manifold, sometimes referred to as an internal heat exchanger or IHX, has an outer and inner tube combined into one housing. The inner tube is connected to the suction line, and the outer tube is connected to the condenser discharge line. Relatively cold refrigerant vapor flows through the inner tube and cools the refrigerant in the outer tube that is supplied to the TXV. Pre-cooling the refrigerant before it enters the TXV increases cooling capacity and operating efficiency of the climate control system. Vehicle AC systems use the physical principles of heat transfer and movement. The AC system is divided into two sides, a low-pressure or suction side and a high-pressure or discharge side. A compressor circulates and compresses refrigerant, while a restriction device creates a pressure drop. Refrigerant absorbs heat and evaporates into a gas on the low side and releases heat when it condenses into a liquid on the high side. The heating system works with the engine cooling system to transfer heat stored in the engine coolant to the heater core and into the passenger compartment.